This is your polar system note. All right, let's go straight over it. Example 1 says r is equal to 1 minus 2 cosine of theta and r equals 1. Our goal is to solve for this equation or this system of equation. Let's do it first with a calculator. What I want you to do is on your calculator, go under modes. On the mode, matter of fact, I will just show you on my calculator. So the first thing I will do is press mode. After pressing mode, you want your calculator to be in radians. Beside radians, you want to also put your calculator on the polar. Radians, polar, and the last thing, you want to move it from sequential to simultaneous. Once you have it on the radian, polar, and simultaneous, by the way, yours will not look exactly like mine unless you have the newest version of the TI-84. But you should still have the simultaneous and the polar part. Once you complete it on the y equal, I want you to go first all the way to the left. Yours again will not look like mine, but you want to keep pressing enter till you get this symbol here. And for the other one, you want to do the same. And you type your equation. Once you type your equation, you go ahead and hit graph. This is what I see on mine. So what I would do is I'll go ahead and zoom it to make sure that I'll zoom, why not out? I'm meant to zoom in. So I'll go ahead and press zoom in. Zoom in, and this is first how your graph is supposed to be. Your graph is supposed to do this. You see how those two circles move. All right, I will zoom it again. Now, pay close attention. Boom. And there's another intersection here. In other words, as you see how, I'll replay it one more time. And I want you to see where those two little circles coincide. Look at this. Here's the first one. And there's another one here. So your solutions are the only time where they are both present at the same moment. So in order for us to solve this, let's go ahead and do it now algebraically. So to solve this algebraically, what I will do is, since r is equal to 1, I will say 1 is therefore equal to 1 minus 2 cosine of theta. Subtract 1 from both sides to get 0 is equal to negative 2 cosine theta. And divide both sides by 2 to get 0 is equal to the cosine of theta. You should still remember how to solve this type of equation. I will find the cosine inverse to say theta is equal to the cosine inverse of 0. Well, when you see 0, you can either use your OI, OU, or OI don't OU, or you can use a coordinate. Knowing that is 0, I know it's on the axis. There are only two places where the cosine is equal to 0. This is one and this is the other. The cosine is 0 at, remember, cosine represents your x. Cosine is your x, sine is your y. And you should know it also, especially since for polar, we say x is equal to r cosine theta. Why cosine? Because x goes with cosine and y goes with the sine. So now we know these 2 points are where the cosine is equal to 0. The first point is pi over 2, and the second point is negative pi over 2. But in this specific case, let's solve it between 0 less than theta less or equal than 2 pi. In other words, instead of negative pi over 2, I will call it 3 pi over 2. What I will do next is I will find my general solution. I would therefore say theta is equal to pi over 2 plus 2 pi n, or theta is equal to 3 pi over 2 plus 2 pi n. Well, that will give me two solutions so far. The first solution is, by the way, these are not the final solution. But before I write the final solution, I will check if the pole is a solution. The pole is when? The pole is when r is equal to 0. So let's check if r is equal to 0. The first statement is 0 equals 1 minus 2 cosine theta. Our goal is not to solve, our goal is to see if it can work. So let's subtract 1. I get negative 1 is equal to 2 cosine theta. Divide by negative 2 to get 1/2 is equal to cosine of theta. Well, I can stop here because 1/2 is less than 1. Remember, cosine theta is always between negative 1 and 1. But if you don't remember that, that's okay. Go ahead and do theta is therefore equal to the cosine inverse of 1/2. In other words, adjacent over hypotenuse. Possible because the hypotenuse is bigger than adjacent. You put a check mark, but that's not it. We just checked the first one. Let's check the second one. The second one says r is equal to 1. But yet we're saying r is equal to 0. So this does not work. Therefore, the pole is not a solution. Because the pole is not a solution, our final answer is the point 1, or the coordinate 1. 1 because the radius was 1 pi over 2. And the second solution is 1, 3 pi over 2. Those are the two solutions, final. Let's go ahead and look at another example. Let's look at example 2. Example 2 now says r is equal to sine of theta and r equal 1 minus sine of theta. So what I would do is I would go ahead and solve this algebraically. The first thing I would do is I would say, since these two are identical based on the fact that they both equal to r, I would say sine of theta is therefore equal to 1 minus the sine of theta. Add sine to both sides to get 2 sine theta is equal to 1, or the sine of theta is equal to 1/2. At this point, I will say theta is therefore equal to the sine inverse of 1/2. Well, for the sine inverse of 1/2, I know that the opposite is 1, the hypotenuse is 2, and I can draw it. Sine is positive in the first quadrant, so I would go ahead and draw it in the first quadrant, where the opposite is 1 and the hypotenuse is 2. Therefore, the adjacent should be square root of 3. So my angle here is definitely a 30-degree angle. Knowing that this is a 30-degree angle, remember sine is the cot, so it's this one. Cosine and his brother sine lie on the cosine, and his brother secant lie on the cot. So sine is the belly, so the next one should be somewhere on this side. So I have one angle theta here, and the other one is possibly here. So what are my two solutions? Because this is pi over 6, I would say the first solution is theta is equal to pi over 6 plus 2 pi n, or theta is equal to 5 pi over 6 plus 2 pi n. Now, so far I can see two solutions, but I still don't know what r is yet. So let me check first for the pole. To check for the pole, we will say r is equal to 0. So let's set it. We have two different equations. The first one I would say is 0 equals sine of theta, or theta is equal to the sine inverse of 0. Well, this is possible. Once again, my goal is not to find that specific angle, to see if it's possible. Now, the second one will be 0 is equal to 1 minus sine of theta. So 1 is equal to the sine of theta. Well, the sign of a number is always between -1 and 1. So it's possible, because I would say theta is equal to the sine inverse of 1. Well, once again, this is possible. When they're both possible, it means that the pole is a solution, and the pole is always at 0, 0. All right, that's not it. Let's go ahead and find what exactly is R, because we cannot write the solution unless we find out what R is. So now that I have this solution, I can just say R is equal to sine of pi over 6. And what's the sine of pi over 6? The sine of pi over 6 is 1/2. If you don't want to use pi over 6, by the way, I use pi over 6 because of this. You can also say theta is equal to the sine of 5 pi over 6. And to find it, you can always graph it. 5 pi over 6 located here, where the opposite 30 degrees is the reference angle. So I have 1 negative square root of 3, 2. So it's still 1/2. Let's go ahead and write now our solutions. These are your solutions. The first solution is the pole, because we find out that the pole was a solution. The second solution is also at pi over 6. No, I can't start with an angle. It's supposed to be at 1/2 comma pi over 6. And the last solution is at 1/2 5 pi over 6. Do not forget to check if the pole is a solution. It is a common mistake. Let's do one more example. Here's our example 3. It says r equal to square root of 3 cosine theta and r equal to sine theta. I'll try to show you how to be organized with this type of problem. The first thing I would do is I would say 2 sine theta is equal to 2 square root of 3 cosine theta. Divide both sides by 2 to get the sine of theta is equal to square root of 3 the cosine of theta. Well, I will divide now both sides by cosine theta to get sine over cosine theta, and this cosine of theta will cancel. I'm assuming now that the cosine of theta is different than 0. Alright, at this point now, I will say tangent of theta is equal to the square root of 3. Well, you should remember that it only means that theta is equal to the tangent inverse of square root of 3. Let's go ahead and solve this. Well, for the tangent to be equal to square root of 3, it means that it's the big belly, first quadrant, where the opposite is square root of 3, and the adjacent must be 1, because this is over 1. Hypotenuse is 2. With the opposite being square root of 3, remember tangent is symmetry over the origin, so the next angle will be here. So, well, this angle is, I'll change color, I'll make it red. This angle is theta, and also this other angle is theta. Reference angle is 60. So I will have theta is equal to 60 degrees, or theta is equal to 60 is pi over 3, by the way. Or also theta is equal to pi plus another reference angle, which will give you 4 pi over 3. The general solution will be pi over 3 plus pi n, and 4 pi over 3 plus pi n. It doesn't matter. One of them is enough because it's tangent. We're finished with this, but that's not all. We got to check the pole. So I will start by checking the pole. Or I can start by looking for r, but I prefer to check the pole. The pole says r equals 0. Two scenarios. The first one is 0 equals 2 square root of 3 cosine theta. And the second scenario is 0 is equal to 2 sine theta. Let's go ahead and explore each of them. Starting with the first one, I will divide by 2 square root of 3 to get 0 equals cosine theta. Can the cosine of an angle be equal to 0? Obviously, yes. Same thing here. I will end up with 0 equals sine theta, and the sine of an angle can be 0. So yes, it's a check. Just by checking both, I know 0, 0 is a solution. That's one. Now let's go ahead and find r. So I will say, what is r? Note that the first step is to set them equal. Find the pole and we'll find out what r is. Where r is equal to, I will use the easiest formula, which is 2 sine of theta. And I will also use the easiest angle, which is pi over 3. Whereas pi over 3 is located in the first quadrant, where the opposite is square root of 3. I have 1 here and 2. The sine is square root of 3 over 2. So r is equal to 2 times the square root of 3 over 2, which is just square root of 3. That's my r. I'll just highlight it. That's the value of r. At this point, all I got to do is write the solution. So what are my solutions? The first one is the pole, 0, 0. 0, 0. The next one is square root of 3, comma, pi over 3. Do I need to write also theta equal 4 pi over 3, square root of 3, 4 pi over 3? Not necessarily. Just like we said, tangent is only one equation, so one solution is enough for the tangent. Cosine and sine, we end up with 2 solutions, and those 2 are important. But tangent, 1 is enough. But in case you wanted to check on the other solution, the one that I say is the same, let's go ahead and find r for that solution. I will say r is equal to, was it 2 square root of 3? 2 square root of 3 cosine of 4 pi over 3. Cosine of 4 pi over 3, 4 pi over 3 located here. Cosine will be, this is square root of 3, negative 1 and 2. So the cosine will be negative square root of 3 over, actually, negative 1/2. So this will have been 2 square root of 3 times negative 1 over 2, giving you negative square root of 3. So the other solution will have been negative square root of 3, 4 pi over 3. These 2 points, based on what you learned on your 8.1 and 8.2, will be identical. So what's the point of writing the same thing? Not necessarily. You write this one in blue, is okay. You write this one in red, it's still okay.